Hello, hello. Hello, Frank. Hello, everyone. Hello, friends, whenever you're joining us from. How are you
Hello.
doing? How are you doing, my friends?
Good, good. And you?
I'm good. I'm good. It looks like you're back
Perfect.
home from your road shows, but I know that there is another road show coming that we are going to talk about.
Yeah.
Yeah. So today, those of you who have joined us and those who are watching, we have a special guest. He has been waiting in the backstage to join us live, and that will happen in 5 or probably 7 minutes. So this is Chris McCord, the creator of the Phoenix framework that lets you create scalable and low latency applications using Elixir programming language. And he studied, exploring and using Yugabyte, and eventually we decided to create this live stream. And then our goal is to support the Elixir and Phoenix community more broadly, because there is a nice match between what Phoenix, Elixir, and Flyo does, and YugabyteDB would provide. So we want to, with this session, we want to begin our conversation and series on how to build those multi-region apps or distributed apps, scalable apps using Elixir, Phoenix, Flyo, and YugabyteDB. But that's what's coming in a few minutes. In the meantime,
So if there are questions in the chat, there are many topics where people can have questions for LinkedIn and YouTube chats.
yeah, absolutely. So get ready with your questions. And even though we have this on our mind for the today's live stream, still, if you have any general purpose YugabyteDB questions that are not relevant for the main topic of today, still go ahead and ask them, because we always want this platform, this live stream, to be a place where you can ask and come and ask the questions that concern you right now. All right. Also, it's interesting to measure how many of you already use Elixir and Phoenix. Just send +1 or give us thumbs up if you already know Phoenix, Elixir, if you know Chris, because we want to see how many new folks are going to watch us today. Because if we see that reaction from you, then obviously Frank and we will give us quick introduction to YugabyteDB once we get to the demo that Chris prepared. So share your comments and we'll make sure to measure. All right, Frank, what do you want to start with? Our usual updates section. What happened in the world of YugabyteDB and distributed Postgres?
Yeah. So in the world, I can share. Let me share my screen to show the home page, and I will put the link. Yeah. So we are doing a roadshow in US, means that we will go to multiple locations to talk about Yugabyte, but also to get networking with people, with customers, with users, with those who are thinking about databases, distributed databases. And we don't do that alone. We do also with partners, because it's always good to share. So there are some locations where we do that at the AWS office in Palo Alto and Austin. And in Boston, we do it in a different place. And we have also partners. For example, if I look there. I know we are there, but I don't know if it's public yet. I think we have Stream, and I think we have also Snowflake, but I don't know if it's mentioned. So do as if I didn't mention anything else. That's what we see on the screen. So Stream for replication. So if you are in Boston, in Palo Alto, or in Austin at those dates, we'll be happy to meet you. For me, it will be the occasion to meet also people I know only from social network, or to meet some customers, and also to meet some colleagues. I will meet some colleagues where we have not met physically before. So yeah.
Yeah, who is the main speaker of this roadshow? Do I know him?
Let me check. I will talk.
You don't need
I
to
will
check.
not say
That's
I'm
you. That's
the
you.
main speaker, but I will talk in all places. So maybe that's the common denominator. And yeah, and we call that multi-region, because we are talking about a multi-region database, and we are going to multiple regions to talk about it.
Yeah, I'm kind of
link
anyway. I'm just I was trying to sell you because everyone, those of you folks who know Frank, you know that he is just undoubtedly one of the best experts in the world of databases, and we usually do these live streams. Like those of you who watch these live streams regularly, you know that what type of demos we usually prepare and show. And this is a cool chance to meet and see Frank, let's say, deliver in a session live, because Frank does this hands-on fashion, very deep dive. He can pretty much cover, I guess, like 99% of all of the questions, right? And he will be able to show them you know just how it works from the coding perspective. Go and see Frank if you live in those locations.
And hopefully we will get a lot of questions and maybe improvise some demo or whatever according to the questions.
Yeah, exactly. Once the presentation is over, I think that you will have an extra time to just to discuss database related topics in a much more informal.
Of course, I guess we will have some drinks after and something.
Okay, yeah, it depends. Like every location has its own favorite drink. If you, what's the favorite? What's the favorite drink in Boston? I don't know. Anyway, so that's the Roadshow. If you're watching us on LinkedIn and YouTube, you will find the link. I see.
So it's not next week, but the week after. So quite soon.
Cool. That's a good point. So what else? Another update. It's product related. Let me share the screen with all of you. Which one is this? I have so many tabs open. Yeah, this one. So those of you who are not new to YugabyteDB, YugabyteDB has another product. It's called Voyager. And with Voyager of YugabyteDB, Voyager is an end-to-end solution for the database migration. So let's say you already use Oracle, PostgreSQL, MySQL, or any other flavor of Postgres, such as Aurora, RDS, Azure for Postgres, and you need to migrate to Yugabyte. So you found the reason to migrate, and Voyager is that solution that will migrate your schema, migrate your data. We support the offline migration, we support the live migration, and what we released a week ago, just on the 4th of July, sort of just to commemorate and to celebrate.
Good day to release something for a US company.
Yeah, the Independence Day in the United States. So the biggest feature, there are a lot of improvements. I'm not going to spend time discussing all of them. You folks will be able to find this on the docs. But the biggest one is the Oracle assessment migration assessment reports. So what that means? Migration assessment reports is another feature that we introduced. It's in tech preview right now. So even before you decide to export or schema or data from Oracle, you can run another command, migration assessment command, that will connect to your Oracle database, and it will create a sophisticated report for you. That report will assess the following. For instance, what's the database compatibility between your target database and Oracle? For instance, how many, when we export this data, right, from Oracle or schema, not just we export the schema, but we also convert the schema to the Postgres sequence, to the syntax that is supported by YugabyteDB. And this database compatibility assesses how many manual interventions would you need to do. Are there any incompatible data types or features that you just manually need to re-implement before you do the migration? Then the cluster size evaluation, for instance, how you already, for instance, you have some Oracle or Postgres database of certain capacity, and then how does it match to YugabyteDB? For instance, how many nodes of YugabyteDB you're suggested to run, and how many CPUs? And that information presently is calculated based on several factors. For instance, how many tables you have, how much data is stored in those tables, and also what's your throughput requirements. Then, some schema evaluation, migration time estimation, and this one is very cool, performance metrics. Voyager will analyze performance metrics of your source database, such as Oracle, to understand the workload, better, and then we would provide you with some of the performance recommendations for YugabyteDB. As far as I understand, in both Postgres and Oracle, they certainly can capture different performance metrics and store them internally, and they will be using that information. So, Frank, in Postgres, we know that we have PG stats, we have different activity, like some system tables and extensions that help to track this performance metrics in Postgres. But what do you usually use in Oracle?
In Oracle, there is a lot, but it also depends on the options that you have. Because in Oracle, even if you have Enterprise Edition, you add multiple packs. So if you have all packs, you have AWR, Active Workload Repository, and views on the performance. But even if you don't, there are some views on performance. Oracle is very well instrumented, and maybe I will add the big value of having this in Voyager is that all the rules, all the experience of different migrations are put in one tool. If we don't do that, then everybody has a different idea because everybody has worked on migration for different applications. A colleague who worked on 10 very big tables may have a different experience than another colleague who have been working on 1,000 of tables. So we put everything in one tool, and it's also a way to give some rules. It's not magic formulas, but some rules to know how we can size a cluster when migrating. Because without that, we don't really know what the application does, how many tables and the size and all that. So yeah, it's kind of putting knowledge, experience, and knowledge in one tool to help migrations.
Exactly. Because what I know as an application developer and what I learned by working with some other customers and users, it's always fun to use a new technology or like some cool technologies. Today we are going to discuss Elixir and Phoenix and then YugabyteDB. But when you do this migration, there is always that boring part. If you already have some running system that works in production, that system might be using another database. It might be using another, application stack. And you still need to have this migration done. And Voyager basically will simplify this boring part for you so that it's less error prone, it's more streamlined, so that you can migrate as fast as possible to YugabyteDB and then just have fun building distributed applications.
And you want to estimate the effort. You know that you will have to change something in the application, but you need to change 10% or 1% or 30%. You want to have an idea when you start.
Exactly. All right, so that was our section where we quickly discussed some of the latest news and updates in the world of Yugabyte and distributed Postgres. And now, without any further ado, let me bring Chris on stage and start with our main topic for today. Chris, how are you doing? How's your morning going?
Good so far. Thanks for having me on.
Absolutely, and thanks for joining us. So how we actually came about this session, I'm very active on Twitter, what we call X these days, Twitter. And then suddenly I came across a post by Chris who showed how he deployed a multi-region cluster using Yugabyte. And he used, some programming language that I was not familiar with in the past, and he used the frameworks. That was Elixir, that was Phoenix. I decided to do a deeper dive, and then I found out, wow, cool. Also, Chris, this is a quite promising language, and even from the language description, like low latency and scalable apps, this is what we do with Elixir, I found some match. And then Chris agreed to come and talk to us, and not just to talk, but also to show how to build those apps. We already have, hi to Chris, Peter, and Kurt. Thanks, Peter, to joining us. Chris, please, because some of us, so right now, I think that right now we have a mixed audience. There might be some of the guys who have no idea what YugabyteDB is, and they will cover that once we go through your session. But also, there might be some of the YugabyteDB folks who just use YugabyteDB, and they might not be familiar with Elixir, with Fly.io, with Phoenix. Just briefly, tell us your quick story, why you decided to create the Phoenix framework, what problem it solved, and why you decided to experiment with YugabyteDB. what was the reason?
Yeah, so I'll try to get an elevator pitch for all three sides here. All right, so Elixir is a programming language that runs on the Erlang virtual machine. Lots of folks haven't heard of Elixir and they haven't heard of Erlang. Erlang's been around since the 1980s, so it predates most programming languages. And it was built for telecommunication systems. And Erlang actually accidentally solved like multi-core before multi-core existed. They built like the perfect platform for the internet before the internet was around. So it kind of started with this idea of running like telecommunication systems where you could have a call and you didn't want that call to go down. It had to be robust. And if you upgraded the system, you didn't want to drop the calls. So it has this idea of like robustness built in. And they continued on for decades and kind of built all these amazing distributed system features before anyone was even thinking about that. And where I came into the picture was I wanted to start building like real-time applications, doing WebSockets. And I was using Ruby at the time, wasn't scaling well. I started looking around. I heard about WhatsApp supporting like 10 million users per server on Erlang. I found Elixir, which was a new language that ran on the Erlang virtual machine. And I just needed a web framework to get this this awesome scalable features. So went off and built a web framework kind of tackling like the real-time problem with like a higher level real-time layer. And that's what Phoenix does. We've load tested it running 2 million WebSocket connections, no problem. It has distributed pub/sub built in because everything's distributed. And before, we'll see some examples of this, but if you're not familiar with kind of Elixir and Erlang, I want folks to think about like, imagine if your favorite object-oriented language had like any instance of an object was just like globally addressable in the system, just by default, where you could just call a method on an object if you knew this global ID. And it just worked. Like you could just say like, give me a new user, and that user was somehow, you could just call methods on it anywhere else. And then just every library had that built in, right? Because it was built into the virtual machine. That's kind of what Elixir gives us. Its concurrency model is distributed. So you can create these lightweight threads, but these lightweight threads are globally addressable. So it's like just the way you do concurrency, the way you write programs happens to be in a distributed systems mindset because there is no other way to do it. So what that lets us do is take code in Elixir and call it somewhere else on another machine, which we'll see in a moment. And that's kind of what I got into with Elixir and Phoenix, and where Fly and Yugabyte come in is like, great, we can do these distributed systems. We have distributed pub/sub, but like, deploying distributed systems is a huge pain. And then Fly built this platform with private networking that just works. And then I was like, great, this is awesome. I can deploy apps that just work. I don't have to worry about the network, setting up the network myself. But then you have the data problem. You're like, the moment you can actually easily deploy distributed systems without a huge team, you're like, well, now everything's still slow because I can run a server in Europe, but it still has to talk to the database in US East 1. So this is where I started exploring the data problem of, okay, I can set up read replicas in other regions with just Postgres read replicas, but then you have the data race problem. So I've kind of like this has been on my mind for a long time of like, I want like the best of both worlds. I don't want to like drop SQL, like, transactions, ACID exists for a reason. So what can I do? And that's where I started looking around to distributed SQL options, found Yugabyte, I was able to deploy it, and I've been having a lot of fun with it. So what Yugabyte gives me, it gives me a ton of things, but what I was mainly looking for was just this, like, how do I deploy a robust cluster and then get read replicas that give me the consistency guarantees that I'm looking for? Because what you'll have is in Phoenix, you'll do a pub/sub broadcast, some distant region picks it up, and then that requires a database read. And we can't guarantee that like that replica is up to date, but can we? Well, with Yugabyte, we can do kind of consistency guarantees where we can always have we can never have a stale read unless we specifically say we want a stale read. So this is kind of the characteristics I was looking for. And then Yugabyte happens to support a bunch of other neat things like X-cluster. We can also do geo-partitioning based on our data, so I can keep the data close to my users where they live. So there's all kinds of other neat things that I'm interested in, but I came in to solve this like consistent read replica problem where I wanted fast reads everywhere, but not have data races. So that's kind of where I entered the picture and started playing around. So there's the quick elevator pitch.
Yeah, this is a quick elevator pitch. You kind of squeezed your timeline, your story in just 5 minutes. And amazing. Erlang VM, just to jump back to Erlang VM, because I'm personally very interested in different virtual machines, because in the beginning of my career and still, I spent a lot of the time working with Java. I know Java virtual machine really well. But what how Erlang virtual machine, truly stood out for me is that virtual machine provides those distributed like auto discovery capabilities out of the box. It's like what folks, like those of you who never wrote a single code in Elixir, right, and that runs on Erlang VM. Let's say that you created 2 instances of your app and you deploy those instances probably in different processes on the same server or across different servers, and then those apps run on Erlang VM. And let's say if one app wants to send a message to another, communicate to another, just using their like built-in APIs of Elixir that look like pops up, like send the message, receive the message, etc. That's all you do. You don't, and your source code looks so simple because the virtual machine handles all the distributed and complexity for you.
Yeah, there's no like tack on library. So it's not like, oh, to do RPC, I needed to bring in an RPC framework, and all my libraries that I'm using and my dependencies have to be aware of this like cross-server thing. It's like, no, like the way we write programs, even if we're not even aware that Erlang and Elixir are distributed, is like what I write on my laptop to run that this process we call our lightweight green threads processes. They're not operating system processes that you can run millions of them on a server. Those are all just, we like to say, location transparent, which is just a fancy way to say that it doesn't matter where it lives on the cluster. I can take this process ID and talk to it from anywhere else, and like that's just built in. So like the way that this manifests for libraries and dependencies is like your code that you write on your laptop can very often just be called across the cluster because it doesn't even have to be thinking about these things because the VM just handles the messaging.
And this is exactly when we discussed with you and with Frank this in the past. This is a big similarity, striking similarity between Elixir apps and YugabyteDB, because in YugabyteDB, I will let Frank to do this elevated pitch to YugabyteDB in a minute, but generally speaking, YugabyteDB is a distributed database, and usually you run it in a multi-node configuration like this. Let's say 3 nodes, and you start a 3-node cluster, and all the nodes start talking to each other. Why? Because they know how to auto-discover each other. You can send your application, Elixir application, can send the request, read or write request to the cluster, and the cluster will decide what of the database nodes needs to handle this request automatically. Same as like in Elixir, right? You send some message, and that message needs to be processed by one of the instances of the other apps, and that app will get this message and handle it. So Frank, let's go to you. Let's do just 3-minute elevated pitch to YugabyteDB for those who are experienced in Phoenix Elixir, but they almost know nothing about YugabyteDB.
Yeah, so the same idea is that you want to distribute the database for elasticity, for high availability, to be sure that the application can continue even if a zone is not accessible. But from the application point of view, you don't want to know where data is physically. So the application connects to any node, see the database, and doesn't care. There is no sharding key to define to tell, okay, my query must run on this node. The application doesn't know it. Of course, you can define if you want your data to be in a specific region. You can do it with partitioning, but you never mention which node. You can mention the region because this can be something that you need from a business point of view, data residency. But everything is distributed transparently. That's the big difference with other sharding methods where you need to know where it goes. So yeah, that's basically the idea. One logical global database that is distributed, but for the application, it's just a database with full SQL features.
And let's say this is a fully open source database. Why? Because those of you who already use PostgreSQL, think about YugabyteDB as a distributed version of Postgres that lets you build scalable and fault-tolerant application. You have an app running on Postgres, and that app, it's easy to migrate to YugabyteDB, because when you start a 3-node YugabyteDB cluster, the query layer of Yugabyte is going to be 3-node cluster of Postgres. Just literally, Postgres will accept your requests and execute those requests over our distributed storage layer. But this is a wonderful, introduction. I think that we should stop here. Those of you folks who will be interested in experimenting with Yugabyte, we have content for a quick start. Today, Chris will show us a true like multi-region environment, we are going to run the demo in across multiple regions. We are going to use, let's say, distributed clusters of YugabyteDB. But if you just want to experiment with YugabyteDB, same as with Elixir, you just can take your laptop, you can run a cluster of a desired configuration on your personal laptop, not pay any penny to a cloud provider. And then when you're ready to go to the cloud, you have Flyover, you have other tools to simplify the process for you. So also we have another feedback from Kate Deno. PubSub and Presence was a real game changer. Yeah,
Phoenix Presence is a feature kind of to answer like who's online right now on the cluster, and without having to shove everything in the database. So that's just built in as well. Yep. It uses CRDTs underneath because it's that's all ephemeral data. You don't need to shove that in a database and then clean it up later. And it's just built on top of Phoenix PubSub.
Excellent. So Chris, let's go to your app. Let's switch to the demo-driven discussion. Show us what you prepared.
We'll do it live. See what happens here.
And hopefully something will break so that we have some headache and we can.
There's a good chance it'd be a learning experience either way. Okay, so I should be sharing my screen now. I may have to. You may have to.
No, this is Frank's. What is yours? This is yours.
Yeah.
Okay.
So you need to change your.
Okay. Alrighty, so let's hop in here. So I have a to-do application that's going to be set up as like a multiplayer to-do application, so all users can see, as I'm adding to-dos, checking them off, you can see that reflected across the world, and then there's also like an infinite scrolling timeline of the activity on this shared to-do list. So this is something that I want to deploy globally with Yugabyte. I wrote it just for Postgres initially, so people that have seen me give a conference talk, it's the to-do check app. The only changes I had to make for it is the CI text extension. I had to remove that and add a downcase unique constraint to my database. Otherwise, it's just worked out of the box with Yugabyte. But before we see the app, I need to actually deploy a Yugabyte cluster. So I'm using Fly.io for that. That's where I work. We're a public cloud, so we're like AWS or GCP, except we allow you to run multi-region, and we give you this private IPv6 network. There's nothing to configure. And anything that runs in a Docker container can just run and talk to other services. So we're great for full stack web apps, like if you're thinking in like Heroku, but then we also let you run distributed databases, or you can just run a UDP service if you wanted to. So you can really run anything you want, from just a standard web app to a GPU powered server somewhere, or a Yugabyte distributed database. So to start, I'm going to deploy a database from scratch and hope this works. So Fly is Docker based. So I have a Docker file here just using the Yugabyte Docker image.
Mm-hmm.
And I have a couple scripts here. Again, I'm not a ops person, which is one reason I love Fly. So this like start script is something I wrote, chat GPT driven, but essentially it's just going to call the YugabyteD program, and with some options to whether or not it's running as like a read replica or a primary. So ultimately, I just want to start a new application, and we can do that with our flytoml file. I have the name of the app, and then I have some environment variables, which we'll use later. But ultimately, I just want to run fly apps create. I'm going to call this YBX5, my 5th experiment here. I'm going to add it to my personal org. And now I have this init cluster script, which is just going to run some fly commands like fly deploy and fly volume provisioning. So it's just like 100 lines of bash that's just going to run like create some volumes for the Yugabyte databases to live on, then run fly deploy, like deploy an initial primary, wait for that to be successful, and then deploy the other primaries. So let's go ahead and run this. I'm going to start a 3-node cluster in like proximal regions. So IAD is like our US East 1. We're going to run this in Boston, and Yule is Montreal, Canada. So we're like within 8 to 20 milliseconds away from each other. So we have some distance there, but they're close enough that latencies won't be too bad. So let's go ahead and run this. It's going to create the volumes. So now that the database volumes are there, we're going to deploy the initial primary to IAD, which is like US East 1 in Virginia. So that's going to go out, take the Docker file, build the image.
I can mention that the storage is local to each instance. You don't need a shared storage because the database itself shares the data.
That's correct. Yeah, these are physical volumes on the host that the machine ultimately lands on. Let's open up the logs and check this as well. Okay, so we can see that the IID node started up, and then it immediately started deploying to Montreal, Canada, and Boston. And those are going to join the initial primary somewhere here. Yeah, so here they passed a join flag to join that initial primary. And now we actually should have a 3-node cluster. Well, let's see, who failed to join here? It looks like Yule wasn't able to contact somebody, and then it retried, and we're good. Okay, so let's see, back in our shell, we should actually have some output that we can follow here. Okay, so it says that we can view our cluster status, and this is one of the neat features of Fly, is this private IPv6 network is run on top of WireGuard. So I'm running a WireGuard tunnel locally, which means I can access my Fly IPv6 network just as if I was running in that network myself. So it's a VPN into this cluster, so I can actually hit the UI app that Yugabyte's going to run for me. So this Yugabyte UI app is running alongside the database that we just deployed. We can see we have a 3-node cluster. It's healthy, and they're all out there and happy in Boston, Virginia, and Montreal, Canada. So the next thing we need to do is configure our data placement, which is basically just like what kind of fault tolerance do we want. So here I'm going to say RF3, so I'm going to replicate to synchronous replication to all 3 of these regions, and I want fault tolerance of a region. So what this is going to give me is essentially any one region can, I have region out capability is what this gives me in a 3-node cluster. So now we've configured that. The Fly SSH console is just a way to SSH into any of your machines, which is super handy. And it just ran that command for us. So now we have this cluster, it's up and running, and the web app that I have is deployed in several regions, and they're unhappy because the database doesn't exist. So let's go ahead and actually see the database real quick. So this is using Elixir's library just to create the database. And again, I'm running this locally because I am VPN'd into the network. These errors are fine because it's trying to pre-cache some tables that don't exist on the database pool. Okay, so now we're running our migrations here, and this is running against the 3-node cluster. And then as soon as the migrations are up, it'll seed some data, and then we can actually try to access the app.
And I folks missed it. I was dropped. Have you guys already shown your cluster? How many nodes? How many?
Yeah, so in the Yugabyte UI we have that's built in. You run YugabyteD and you get this UI. It tells you kind of the cluster configuration, and now we can see that we have some data and some tablets because we just seeded some data. So the web app should be happy now. Yeah, so their database connections are actually starting up now because we have a database for them to connect to. And if we go to this app, you can log in. And this is deployed in IAD on Fly and in Warsaw, Poland, Sydney, Australia. And we can see what kind of like reads and write speeds we get out of the box. So this bottom corner here is, this is a server rendered web application using Phoenix Live View, but this bottom corner is just the server time. So regardless of how long it's taking the client, that's a 15 millisecond read to load all the to-do lists and their 100 odd to-dos here, which is pretty nice. So this is 10 millisecond read there as well. Go ahead.
Yeah, so quick question. Yeah, this latency, 15 milliseconds, 7 milliseconds. This instance of the app runs also in the United States? Or where is
this
your
is in IAD. So the way Fly works is at your app URL, it's going to route you to the closest region of the request. So this app's running in IAD, Warsaw, and Sydney, Australia. So it routed me to IAD. So this web app is connected to the IAD server, and the way that works, which we can talk about real quick, is in my runtime configuration, Fly gives you like a super handy DNS-based discovery across all apps in a given organization. So this web app is named To Do Trek, but since it's part of the org that the database that I deploy to exists in, I can just say like top 1, top 2, top 3 nearest of, and then that app name .internal. So the IPv6 network spans applications in an organization. So the Fly web application that I deployed here is going to just say, give me the top 2 closest addresses and connect to those. And that's going to be for the app that I'm hitting locally, that's going to be Virginia. So it's going to hit the same data center.
That's really cool feature, yeah.
And
Yeah,
this
super
and
handy.
this, and this infrastructure, this discovery of the closest machines, is it provided by Fly? Right, it's provided by Fly or?
Yeah, it's just built in. So this app I deployed from scratch, YBX5, didn't exist till we started the stream, and then this DNS-based naming and discovery is just built in. And then it
So generally
spans,
speaking,
like
cool. So that 15 milliseconds latency, this is what your application that is deployed in the United States East Coast will get by working with the database that is also located in the United States East Coast, right? Because the traffic by default will go to from the East Coast to the East Coast.
These are essentially in the same data center. This web app and that Yugabyte primary, but it's going to do consistent reads. It will fall back to follower reads, which we'll talk about in a moment. But we can see that that was sub 10 milliseconds, right? So if I experience a side effect here, that write took 120 milliseconds. It was too fast. Hold on. Experience a side effect and refresh. You can see it now it's 76 milliseconds. So it fell back to a consistent read, and now we're back at 7. We'll talk about that in a moment. I want to talk about replicas first. But what this has given me is, my reads are still, my consistent reads are still super fast in this 3-node cluster configuration. Write performance does suffer. So let's see, I'm at like 100 milliseconds for, checking a to-do. So about 80 to 100 milliseconds on average for this particular configuration. It kind of just depends on how far the nodes are apart. So for many applications, this is acceptable. We can also talk about Yugabyte has a feature where I can set a preferred region, where essentially I could just say the IAD region is the preferred region and always assume it's the leader, and then that latency is going to drop. And my understanding is at the cost of maybe some slight latency for failover scenarios. But I think that a natural step here, if you wanted faster write performance, would be to set a preferred region. You all can correct me if I'm wrong.
Yeah, it depends also. It depends on your cluster configuration. That 3-node cluster, do you run every node in one of the regions, different regions?
It's 3 individual nodes running across those 3 regions.
They're also different regions. Yeah, usually the latency between regions is higher. Yeah, usually the latency between regions is higher. Those of you folks, and you do this multi-region setup of the database. If you want also to tolerate region-level outages, if that's not your goal, if you want to tolerate zone-level outages, then guess what? You can deploy your multi-node cluster within the same region, but across several availability zones. And by doing that, you will slash this write latency, let's say from 80, 70 milliseconds or 100, depending on your distance, to like 5 milliseconds or 10 milliseconds, because this is what you're getting with a multi-AZ setup. So many options. Yeah, it's... that's a different topic.
Yeah,
let's carry on with you. Yeah, let's carry on with you.
It's a good point though. It's like you have to, for any kind of distributed system, you have to pick what trade-offs you want. Right? Basically, the speed of light is this pesky problem that we still haven't figured out how to solve yet. So it's like, you have to depend on what trade-offs you want. So this is why I picked like 3 proximal regions, just because I would have essentially like, data center level outage support here, or, some hurricane comes through the East Coast, and then I'm still well served. So you kind of have to answer those constraints of your application. But in this kind of default setup, a 100 millisecond write is fine. And then especially in this case, this app is using like optimistic UI because you essentially checking a to-do, you don't expect to fail. So in this case, that write performance is fine. If I add new to-dos, that's totally fine for this use case.
What I like is that you show how the performance is perceived by the user, because we can look at the number at the milliseconds and try things, but finally what we want is that the perceived performance from the user is okay and still being highly available, so on nodes that are not too close and not fail at the same time.
Yeah, and if we nuked the IAD node, database node right now, like the app would just continue to work. It wouldn't care about it, which is super neat. And then we can see a higher write speed here. This could be, I can optimize this at the app level, but if I drag it to do, it actually has to do quite a bit of work. So that took about 500 milliseconds. But again, the user isn't experiencing that. But that requires moving the to-do from one list to the other. It's got to shift all the positions of both to-dos in the list. So that transaction is doing, several reads and writes. And that's why we see like, all those reads and writes within that transaction have to be consistent across the quorum of those servers. But in this case,
maybe
for this
I
app,
can mention
totally
something. I can mention that when you write, it has to wait for the quorum, so for distant acknowledge, but not for each write. They are batched so that you have the latency, but you don't want the latency for each row. And this is why it's a bit slower, but it's not the latency multiple times for each row.
Yeah, Yugabyte's going to batch what it can. And then we'll talk about batching in a bit, because it's going to batch what it can, but the nature of SQL is like if you do a read followed by, if you need to do a write and you need to do a read first, like the database SQL, like it can't know that, it can't basically plan that out. It's not deterministic. So we'll talk about like ways around kind of doing these hops back and forth once we set up the read replica. But so this is all good. Like we're happy with the performance here, right? But now if we say like, well, what about our users in Warsaw? And this is another neat feature of Fly, because I can't easily, I can set a header and actually have Fly route me to a region without going through the IPv6 network. But since I'm VPN'd in, I can actually just use the DNS-based region name. So I can say www.edge2do.internal. That web server is running on 8080. And because I'm part of that private network, I can actually just hit the app. And now I've connected to the Warsaw application and skip the Fly proxy. So instead of having the Fly proxy take me to the closest region, I'm saying, no, I want to go to Warsaw directly. And this is going to appear slower. So we have to talk about what's going on here. So this is going to Warsaw and back to me over the ocean, right? So it's like double the performance hit of how this app is feeling. But this number here in the bottom corner is just what was experienced by the Warsaw web server. So we're getting about 500 millisecond read time in Warsaw just with this 3-node cluster configuration in North America, right?
Yeah,
so we could say that like...
Yeah, what happens, let me just explain also this to those who know Yugabyte. So what, Chris, you just deployed, you deployed the same instance of the application, web application, but in Warsaw, in Europe. And that application pulls all the data, all the to-do list from the database. It needs to have a consistent copy of the data. And the database is deployed in the United States. So the requests need to travel from Poland through Europe under the Atlantic Ocean to get to the database in the United States and all the way back. So that's why the higher latency, but you're getting the consistent result. All right, let's see. And can you also show that, I think that you're planning to show that how those two instances, you have the instance of the application in the United States and Poland, how they actually talk to each other, because I truly love that capability of Erlang and of Phoenix and Elixir, the pub/sub feature.
Yeah, as soon as we set up the read replica, I'll jump into an Elixir shell. But yeah, we should show off like the multiplayer aspect of this is my. Let's see. Let me make sure I'm actually. Yeah, Warsaw on the left here, and then this is IED on the right. And we can see that like it's almost like localhost speeds, and this is including the write latency. So this includes 100 milliseconds, and then we do the pub/sub broadcast, and it goes back over the ocean, and like. Right? Like you almost don't trust it. You're like, what? And then I can like rearrange to-dos and it will also be reflected. This one you could feel the latency a little bit because it takes a little bit longer. So yeah, and then adding to-dos is the same deal. So if I go ahead and down here, I'm going to delete one. We can see it was deleted, and then here I can say like,
for the user, it's in real time. It's truly real time. And imagine, folks, that you just have you live in the States and you chat to someone, I know, on WhatsApp, Telegram, etc. And this happens instantaneously, and all those messages are consistent. Can you quickly, just before you go to the replicas, can you open the source code of your app and show how that communication takes place? Because many of those who watch us right now, they will be surprised how the source code looks like, because it's basically like those built-in pub/sub capabilities of
Elixir. Yeah, this is a good point, because if we look at the write performance of Warsaw, because like our goal is to get these read performances down, but let's just look at the writes, which our writes need to go across the ocean. So in the case of like removing a to-do, that would require multiple hops if we issued that transaction from Warsaw, right? If we just connected to the database with our Postgres driver, and we see it was 582 milliseconds, which is quite close to what we have just in the primary region, which is 463, right? So it's basically just the same latency as primary plus the single hop across the ocean. So if we were connected directly to our Yugabyte over Postgres and we tried to do this, Yugabyte would batch what it could, but it wouldn't be able to batch these operations. So what we're doing in this case to avoid, a 4-second write time is doing an RPC call with Elixir and running the transaction actually in the primary region. So that's what I think Denis was alluding to here. So if we go into
And so Chris,
our Elixir code.
Yeah, while you're searching for the Elixir code, let me share the feedback from YouTube. This is crazy. I'm hyped building a global Counter-Strike gaming platform. Actually, it's even much more suitable for gaming. Not much more suitable, but also for the gaming when you need to have that real-time nature. By the way, Frank, I remember seeing some other questions in the list, but I no longer see them because my connection was dropped. If you can show the comments and the questions from the folks, can you check in our studio?
I think we have seen all questions. Yeah, there were a question about is the geo capability available also on open source, and I just answered on LinkedIn that the whole database, the whole Yugabyte database is open source. There is no community edition, enterprise edition. The software is all open source. Yeah.
And also, I see the following question on LinkedIn from Alessandra. For some reason, it was not shown here. Not Z. I don't know what Z means. Chris, do you have any idea?
I've seen the question, but I didn't know what it is. Yeah, good.
Z, probably editor. I'm using VS Code here with Vim emulation. I think they're probably asking about what editor I'm using.
Okay, then. Sorry for interrupting you. Go forward.
Yeah, no worries. Yeah, Yugabyte. Yeah, no features, or there's no feature gating, unlike some other distributed SQL databases. So multi-region, everything you want is just going to work. And then this is the Elixir code that does update to do position is the thing that's taking quite a few hops back and forth because it has to do a consistent read, make sure that to do is still part of the to-do list. It has to reposition all the to-dos in that list, and then it has to insert into the activity log. So there's 3 hops here potentially across the ocean if we weren't doing this in a single hop. So how do we make it a single hop? Well, our Elixir code built into the database library has like a transaction function, which is just going to take a function, and if it succeeds, commits it. If it fails, it does a database rollback, right? Nothing spectacular there. So I wrote a function called transact, which is going to do the same thing, but it's going to do an RPC call and take all of this code and just run it on one of the primary Elixir servers that we know is running close to our Yugabyte primary region. And the neat thing about Elixir and Erlang is this function, everything that closes over, any data structure that we pass in here, like this scope is a rich data structure. This function is kind of location transparent as well, right? We can just say like, hey, run this code on another node, and we don't have to change the call site or anything else. So that's what we did to get around this multiple hop problem for writes that can't be batched. Is this transaction function is basically just going to do an RPC call and run that function on a node that says, on any web node that says that they are in the primary region. We're only running one right now, but you could be running multiple, and it's going to randomly load balance and pick one. I won't run into much of the RPC code, but like this is 30 lines of code to make this work in Erlang. I mean, it can be 0 lines of code, but the only thing I had to do was the nodes have to say, like all the nodes discover each other on the cluster, but the nodes that are part of the primary have to actually say like, hey, I'm part of the primary. And we're using a process group to do that, which is also just built into the standard library. So all we do for the RPC call is we look up the nodes that say that they're a member of the primary. If we don't find any, we actually just fall back to invoking the function locally, which is fine because our Yugabyte connection is still established across the ocean. So we will just degrade. If for some reason we can't contact the web nodes in Virginia, but the database is still accessible, or North America is still accessible, it will just degrade to a slower experience, but will still work. Otherwise, we just randomly load balance to any Elixir node, and we just pass that function. And this func here is that anonymous function that closed over all its state, and that code will just run elsewhere, and the result will be returned to the caller.
How do you make sure I'm not sure like if this if the current logic supports this, but what if I have several primaries? How do you make sure the function is not executed twice, only once? And
so this RPC call is just a single RPC. So there is RPC multi-call. You'd have to explicitly like invoke it multiple times yourself. This is just find one and invoke it. If it's a member of, if it's itself a primary, it just invokes it locally. So we don't have any risk of double execution. It just picks one.
I see what it means. Okay.
And if that fails, then it's just going to roll back it's just going to raise against the caller just like it would anywhere else. And we can see this in action real quick because I think it's, it looks pretty fantastical and magical. So we can apply SSH into our web app, and any running machine, it will just pick the closest one, which is IAD here, and I can actually get a shell and a REPL into my running Elixir app. So I can say appbin to-do-trek. So now I've got a REPL into my running app, and I can say like node.list. And this is where we can see that the Erlang nodes just know about each other, and these are their addresses. We can see their IPv6 address. And here's where I can show, like, I can just run code elsewhere. So I can say, for node in the node list, and then I can run that ERPC function. I'm going to call each of those nodes and send a function over there. And let's say like I'm going to read from each of those remote nodes their fly region environment variable, just to say like, okay, let's see, like, where are we running? Where do those live? Let's see if this works. Yep. So there's the RPC call. We can see Warsaw, Sydney, and I have one in Hong Kong as well. And the current node that I'm running this from wasn't included in the node list because it's itself. So yeah, this function, again, like I said, I can just send code to run elsewhere, and the Erlang VM will run that, redirect it to the caller. Any IO that you do there also can be redirected to the caller, which is really neat. Any files that I open on the parent, I can do distributed file IO. If I do a file read on the other node, it will actually just like stream the file over. So there's all kinds of neat things built into this, but this is how the transaction, this is how I'm grouping transactions. So this is all to say that the code that I had to write to make my slow transactions in Warsaw fast was, almost nothing. We go back here, all I had to change was, this used to be repo transaction, right? I wrote my own transaction function that happened to just pass that and do an RPC call that just calls repo transaction on the other node. And none of my other code had to care about it. Amazing. And this grouped, again, this is kind of like almost like, batching, but batching everything in one hop.
Excellent. Brilliant.
And that's what gives us these as fast as possible writes, because we're only making one hop close to the data, or close to the primary in that case. So yeah, so Elixir lets us do kind of these neat things like this. But what we really want is to make...
add something. Pascal, I'm sure that people will love this question. If with the application you can batch the writes, why the database cannot do it? And I will answer it. The database doesn't know what you do with the application. So when from the application you are doing some reads and writes, the database itself cannot do everything asynchronously and mix the order, because it doesn't know what you will do with the results of those reads. So this is why it cannot be all batched and must be flushed between. From the application, you know exactly what you do with the results. So from the application, you can do more batching, you can do more optimization. The database can do only the optimization that will not change the behavior of your application without knowing your application. So that's really good to be cool to be at the tool level to have those optimizations.
Yeah, that's a great question, because I mean, to give a concrete example, it's like I do a consistent read here inside this transaction. And then based on the data I get back, I do additional writes. So there's no way for the Yugabyte or Postgres or the SQL spec to know that a deterministic way to send these in one operation, because what I read here is going to potentially determine what I do here. And again, this is all arbitrary Elixir code as well. So, it's like I can have branching logic based on the read. And there's no way to group that logically unless you had some kind of like meta DSL or something that where you sacrifice some things.
That's the problem of you. The database doesn't know all your intents at the beginning of your transaction. Until you commit, it doesn't know what you do in your transaction.
Yep. So we have our optimized writes for hops, but we still have this pesky slow read problem, across the planet in distant regions. So Yugabyte has a great feature for this, which is going to be read replicas. And I'm going to deploy a read replica first, and then we'll talk about consistency, because, my whole goal with all this is to have consistent reads. But then if you want consistency in a distributed system, you have to sacrifice something, right? So it's like, how do we get fast, consistent reads? So I'll talk about that in a moment, but our goal is to get this read replica set up first, and then we'll see how we can kind of get the best of both worlds. So if I go into my Yugabyte cluster, I'm going to set up a read replica. So I need a volume for that data to live on fly. So here, YBX5 is the app, and we're going to set up a volume. We'll start in Warsaw. So that's going to create a volume for us. And now I need to add a fly machine to this running Yugabyte cluster. So I can say fly scale count, and I'm going to add a new region, add one machine to a region in Warsaw. And you can see the fly planner is going to say, you have an unattached volume in Warsaw. Would you like to add a machine and attach it to that volume of this size based on the other sizes I have deployed? So I say yes. And if we check the fly logs, it's immediately in our data center in Warsaw deploying the Yugabyte container. And we should just see in a matter of seconds, we should have this up and running. And it joined the initial primary. Yugabyte's running its system checks, getting all the information. Okay, so we have a replica node that's joined. That was from scratch across the planet, which is pretty cool. And if we refresh our UI, this is our IAD UI, it does see the Warsaw read replica, but we can see that we have no tablets, which is like, where our data is stored on the read replica. So this node is up, it's discovered, but it's not actually, the cluster isn't configured for read replicas yet. So part of the init cluster script told us how to do that. If I scroll up here, we can run a configure read replica command. And the fly SSH console here, if you pass -s, it will give you a switch to pick any machine running in the in this app. So I'm going to say SSH into Warsaw. And I'm going to run that command. In my replication factor, I'm only running one read replica at the moment. So we're just going to say rf1. Okay, so now primary cluster will begin asynchronous replication.
Yeah, so a good point to make. Those three primary nodes that you have in the United States, right? Those use the raft consensus protocol to replicate changes synchronously within the cluster. So whenever you issue write requests or read requests, you always deal with the consistent and the latest version of your data. Read replicas, they are not involved in that raft consensus protocol, and read replicas basically keep your replica, and the changes from the primary cluster are delivered asynchronously. But what Chris also discovered, I know that you love this feature, that when we replicate changes asynchronously from the primary cluster nodes to the replicas, there will be some data lag because of the asynchronous replication, but all of the data on the replicas will be in a consistent state. Let's say that you executed some multi-table or multi-node transaction on the primary nodes, updating several tables, several rows, and you will see those changes on the replica side only when, let's say, the entire transaction was fully replicated. You will not see an inconsistent view. Right, Frank? This is accurate.
Yeah, it's timeline consistency. It's consistent not with the latest writes, but all the objects you read are all consistent as of the same point in time, the same read time. Yeah.
Excellent.
Yep, and we'll see an example of how that plays in. So yeah, it looks like it replicated all of our data to the read replica. I had to bounce it was perfect time to talk about how read replicas work, because I had to bounce my Warsaw web server because that top two nearest database connection discovery was still going across the ocean, right? So I just bounced the server so it would connect to the now closer Warsaw web server. So that should be up and running now. So if we go back to Warsaw, sometimes it takes a bit for the database connections to actually warm up. We'll see if this actually works this time. Hey, look at that, Demogods helped us. So yeah, so this is again our Warsaw server, and the page is going to appear to load slower because again I'm VPNing across the ocean, but the actual server fetch time was 6 milliseconds. So it was 500 some milliseconds.
Yeah, and also with replicas, at the very first connections, if you use a connection pool, you will have several connections open through replica. And when you execute the very first requests, they will be slower. Why? Because there are some system-level cluster metadata, database metadata that is stored in the United States. And when you start sending requests to the replica node needs to pull that system metadata from the United States, bring it to Warsaw in Poland. And that's why the very first queries will be slow. But once this metadata is here, take a look here. It always takes like 5-6 milliseconds. So right now, the cool thing is that whether your users live in the United States or in Warsaw, for them, the read latency will be the same. And they will see a consistent data set.
Yeah, so we have like 3 milliseconds. It's actually faster than the primary region's replica stale reads, which is pretty fun. So yeah, 3 millisecond read. So this timeline here, 3 milliseconds to paginate the timeline data. And so, what are we sacrificing here? So the way this works is this can be fast because we're doing a stale read, right? So the whole idea of read replicas is like, if I want to read the data locally, that data, if we want it, it's going to be consistent by default. So if I just do a read there and Yugabyte, I don't tell Yugabyte I want a stale read, it will redirect the read as a consistent read back across the ocean. So like the default behavior is like consistency, right? Which is what you want from a database, which is shocking. You have many NoSQL options that ignore that, but you want consistency by default. But the idea with read replicas is we can do stale reads and what Yugabyte calls follower reads. So this read replica allows us to say, you know what, I'm willing to do a time-based staleness, and then I'll just read from my data locally if I can. And if the time-based staleness you give me, I can't guarantee a consistent time-based read there, I will still re-forward to the primary. So we can get consistent time-based stale reads. And I'll explain all this in a moment with an example, but what ultimately we can get is a stale read that's going to be guaranteed consistent from the from the user's point of view. And the way we're doing that is I'm keeping a last observed side effect. So I'm going to go back to my primary region because it's too fast to see on the Warsaw page reload. So we can see that I have 8 millisecond read back on my primary region. If I experience a side effect from the user's perspective and then I refresh, it did a slower read there and I still see that checked, right? It wasn't like in a Postgres replica scenario where I refresh and I miss my write and now it's still unchecked because I did a stale read. No, it's like every time I experience a side effect from the user's perspective, whether that's doing interaction on my screen or someone else collaborating, I keep a last observed side effect timestamp in a cookie. Mm-hmm. We can actually observe that. And I'm using that to drive all my reads then for the interface. So let me see if I go to application here. I mean, it's similar to what, probably what Raft is doing and Yugabyte's doing internally to track its own side effects. But so I have this last side effect cookie, and what I'm doing is, if I just do a hard refresh here, that last side effect was like 30 seconds ago. That's no problem. We say we know that the user's seen data up to a certain amount of time in the past. If I check it to do here and I immediately refresh, that's going to be slower than I think I have a cap at 2 seconds. If it's within 2 seconds, I don't even attempt to do the stale read because I know that Yugabyte's probably going to redirect it anyway. So I'll just fall back, and then it took 70 milliseconds. And if we refresh here again, we're back to 7. So we're getting a stale, consistent read, which is always going to give the user the data that they expect, if that makes any sense. And we do that by passing up a cookie, and then the code in my Elixir land, I'm already passing in this scope data structure, which is using, it's got current user knowledge. It's where you would do authorization level, role-based access. So this scope also now carries the last observed side effect as far as this scope was concerned. And so all I do in this case is, well, this is a write, so it doesn't matter. Let's go to somewhere where I'm doing a read. Yeah, so this active list, I was already passing this scope in. So now I have this replica repo stale function, which is going to say like all of the queries I was doing before, I want to attempt to do a stale read. And this stale read is going to be guaranteed consistent from this current user point of view.
Yeah, because of
and all that's doing is setting a Yugabyte follower read time. This is just a stored procedure, so I don't have to expend an extra hop. But essentially, all that thing is doing is just setting a follower read. If you check it out.
Yeah, this is actually one of the areas. Yeah, go ahead.
Yeah, go ahead.
Yeah, this is actually one of the areas where YugabyteDB can improve from the user developer perspective, because what happens right now, I think had to do this in the application code, because
I didn't have to. I wanted to hyper optimize, right? Like you can go ahead and explain, but I didn't want to experience the three hops.
No, yeah, and also let's say that if you use that database server, if you use the database instance, not database, application instance in Voyager, and you do any change, that change will go to the replica. And the replica, once the replica responds that the change was accepted, if you read it immediately from the database, you might not see this change. Why? Because that change is yet to be replicated from the primary. So right now, when we acknowledge this transaction that was sent from the replica node, we do not send back let's say that the current state of the data. And what you actually did, what might have happened if you did not have that feature. Let's say you're doing some update from the Washer, you check mark this to do, but then you're refreshing the screen, and that to do is unchecked just because that change was not asynchronously replicated to your replica node. So it's like Oracle, I know, support this feature, and hopefully YugabyteDB will support this as well.
I see. You're saying that the replica itself would know that I had performed a write and just
it will no, it will get an acknowledgement from the primary cluster that the write was accepted. But if you try to read the same record from the replica right away, it might not be there yet.
See, I could even drop this. Yeah, that'd be awesome if I could simplify. But yeah, the last observed side effect, it is a tiny bit of code to make this work. So it's like I had to write 5 lines of JavaScript to anytime we experience a side effect, I just tell the client to set a cookie, and then that way, if they revisit, hard refresh, whatever they do, I know the last thing they saw. And then the staleness window is like I said, that if it's less than 2 seconds, I'm just going to assume that we can't meet it. It's got to be, I think it's got to be what, twice the Raft heartbeat window, which is by default half a second. So it can't be any faster than a second.
And also because it has to take into account the clock skew. You are not sure
right,
about
the clock skew plus Raft heartbeat. But the neat thing is that as long as I don't give it, if I try to give it something below a second, it's going to error as it should. But the neat thing is, like, if I try to do an aggressive, let's say like just over 2 second read right after I experience a side effect, it's going to know that if it can fulfill that or not and just redirect the read. So like I said, it gives you the performance when you want. And in the case where you would race the staleness, it's going to redirect the read as a replica, or sorry, to the primary. So we can see that, I'll show it again, where this was 62 milliseconds, which was still fast. So it gives us the consistency, even though we're doing a stale read, which is like something, the qualities that we don't get from a, non-distributed SQL solution. You can either try to tack on, a bunch of hacks around that, but this is kind of giving me the best of both worlds. So this is how I'm able to get, fast reads in Warsaw, which are faster than, so 5 millisecond reads there. And then we'll see if we can catch it. The problem is I refreshed it before the cookie was acknowledged. The problem is that the refresh is slow enough that the data I can't catch a stale read. Yeah, so
it's hard.
See if I can get it again. Yeah, it's at least 2 seconds, and then it's going to be fast again. Yeah, so I can't even, 6 milliseconds. Yeah, so I can't catch a stale read easily from Warsaw, but yeah, so that's the idea. So if I wanted to run a read replica in Sydney, Australia, I would just go through the same flow. Instead of the configure read replica new, I'd say configure read replica modify, and I'd pass it RF2 for 2 read replicas, and then YugaByte would just start replicating the data to Sydney. And that's where I can, serve my users wherever they are and get, fast reads and fast, stale, but consistent reads in my application. Yeah.
Excellent. So thanks a lot for the demo. We have a bunch of questions.
Demo,
we'll get to the demo. In the meantime, let me just quickly recap on this multi-region setup. So you have the primary node cluster in the United States, 3 node changes were replicated across multiple regions. That's why the latency was higher for writes. But the goal for this demo was to achieve the low latency across all of those locations in Voyager and in the United States. And in the United States, the latency was low for those who live in the East Coast, just because those clients, that application instance is close to the primary database node. But originally, initially for the Voyager location, the latency was high because the application needs to go to the United States. And you solved that latency problem by using the read replica approach. Also, folks, in YugabyteDB, we have other solutions. The read replica is not the only one option if you want to achieve low latency writes across, large locations. We have other kind of patterns. We call them design patterns. There are 8 design patterns, and some of the patterns also let you achieve low latency reads and writes across those locations. But this is a different topic. If you're interested, you will be able to discover. Now, let's check through the questions. The first one is from Play for Steak. Not sure if my comment disappeared. Probably either any official Fly.io guide to how do the setup of YugaByte. This is a homework for me and Chris. So Chris, you can.
Not, I mean, my Bash script is open source, but ideally this is, this isn't my fumblings. So ideally we get like YugaByte anywhere at a minimum. That way it could be anyway, my goal is a turnkey solution on Fly. I mean, it's I can share this bash script. It's actually just on my personal GitHub, and folks are welcome to use it. But this is definitely prototype level, me exploring Yugabyte more so than a production ready bash deployment script. But yeah, we have some homework to do. I think we can make this turnkey and give folks what they would want from a production ready setup on the fly.
Yeah, I can collaborate with you on this. We can discuss this offline. Probably even for me, it would be beneficial just to create something, sort of a getting started guide. And that even just before we create something for multi-region workloads, we can select just a use case of one region on Fly.io. How do we use Elixir, Fly.io, and YugabyteDB to set up just a database cluster in one region?
And I think you all provide the Docker images, so really the Fly specific parts are just the DNS-based host names. So folks look at the bash script. It's really just how do these nodes advertise themselves and discover themselves.
But it would be good if we write an article about that, all the networking things on that. And also, we usually talk about zones, region, cloud, and in Fly, they are all region as far as I know. So yeah, maybe good to write about it. Yeah, we will do it.
Yep.
Excellent. Let's move forward. Yeah, this question Frank has already answered in writing, but in Postgres I can use logical replication to set up something like CDC? Can I still do that in Yugabyte without relying on Debizium?
So I mentioned that, yes, we have change data capture. We use Debizium. I think we had a project to do the same without Debizium, but there is no high priority on that. So Mohammed, if you have a use case and a good reason not using Debizium, please tell us. It can help to raise the priority of this alternative.
And also, just in case, Mohammed, because I want to better understand the context of this question. In Postgres, you use logical replication to stream changes from the primary instance to replica nodes of Postgres. But in YugabyteDB, what Chris showed us today, he was running, let's say, multi-region cluster, and he used the replica node. He did not need to set up any replication. Replication is built into YugabyteDB. So when you run that 3-node cluster in the United States, we use the RAT consensus protocol. We use synchronous replication. You don't need to do anything. You just start your node. When you need to replicate changes from the primary cluster nodes to your replicas, then we use a synchronous replication. But again, you don't need to do anything. You just, what Chris showed you, just start your replica node, attach this replica node to the primary cluster, and that's the black box for you. You don't need to do anything else. CDC, the CDC feature that we have, that is based on Debizium, as Frank says, it's necessary if you want to stream data from YugabyteDB to another data source. It can be another database, it can be another, let's say, Kafka cluster, etc., etc. This is when you need to pull data out of YugabyteDB to some other external system. This is what CDC is used for. Hope it makes sense. So let's move forward. We have a question from Eduardo. Eduardo promised us to take a look at this solution because his goal, Chris, is to migrate from PHP to Elixir Phoenix, and the database was the great question. Yeah, Eduardo, you can stay in touch with all of us, 3 of us, and also just connect with Frank and me if you have Slack, community Slack on YugabyteDB, and I guess that for Elixir, the Elixir community is also very responsive. So let's go in chat if you want us to help you with the design and prototype. We are here to help. We're not going to charge you for this. You're not going to pay for this. All right. What else? And the next question is by Eduardo as well. Is Phoenix supporting YugabyteDB natively or just use the Postgres reference to create a new project? Presently, Chris, if you can show one more time, we're using just Postgres drivers, right?
Yeah. So the only change I had to make was the authentication generator for user sign in. I was using CI text column for uniqueness constraint on email, and I had to make that a lowercase based index constraint instead. So it was like 2 lines of code change there. So this is all to say that the Postgres driver in Elixir just works with Yugabyte, but the Phoenix generator, I will have like a -s database Yugabyte. I will add that. It's like a 2 lines of code change. Basically, the only thing it will do is not set up it will avoid setting up the CI text extension. Similar thing to, I added a cockroach DB flag. So it's pretty much already supported natively because it just works with the Postgres driver, but for a Phoenix new project, if you pass that flag, you can save yourself a few lines of code.
Wonderful, wonderful.
So the problem was that we do not support CI text or indexes on CI text.
My understanding is
we
just
have an
CI
open
text in
issue about
general, but it could
Okay,
just
yeah.
be indexes. It was giving me an error like not supported. Like I said, not the end of the world. It was just that's the only error that was thrown when I ran my migrations, and it was a couple lines of code to fix.
Yeah, I think we have an issue open, and it's probably not difficult, but as we have different indexes than Postgres, if there are special data type, we have to check and validate that.
Yeah. It's easy to trivialize, especially a distributed systems problem. And then a question that came up on Twitter actually was about Oban. Oban is is Elixir's job queue, kind of go-to job queue library, and it's backed by Postgres. And someone asked about Oban support. So I think the Oban author is actually worked in. Oban uses advisory locks. So up until I think a couple weeks ago, it was not going to work because advisory locks aren't supported. But Oban doesn't need to be using advisory locks for the reasons it's using it for. So my understanding is either on a branch or on the main branch, Oban would just work with Yugabyte today. So if you're not using latest Oban, definitely check it out, and it should work either now or in the very near future because they dropped advisory locks.
And we will have to support advisory locks. I think it's more than we are looking at the different use cases to implement it.
I feel like that would be very difficult.
To be scalable, yeah.
And I think that's the only case that I've. It's actually interesting. If we have more questions, we can get to it. But I was using advisory locks in this application initially for locking like the to-do list. Moving a to-do from one list to the other. I was using an advisory lock. And then when I found out Yugabyte wasn't going to work with it, basically it turns out I should have just used just regular row level locking. Like there was no reason for me to be using advisory locks. It should just be what you saw in my code. Select the row, lock for update, done. So part of that was just my really lack of SQL knowledge and just knowing advisory locks were a thing. So I think Oban, was able to drop advisory locks without any kind of performance penalty. It was just, I think it actually led to better architecture, if I remember correctly.
Yeah, so looks like, guys, you're answering this question, and I just showed this question by Mohammed for everyone.
Publish notify. I don't know if Frank or Denis, you could speak to that. I'm actually not aware what Yugabyte's story is there. I haven't tried it.
Yeah, it's the same idea. It's a feature. We can implement it, but we want to be scalable. We don't want to implement something that is not scalable on a database that is there to scale. And publish notify, we need to see how it is used to do it, because basically it will serialize everything. So yeah.
I see. Yeah, and
it's
in the context
open issue.
of Elixir,
it needs more priority, and it needs also more understanding about how it
has trade-offs. Yeah. And in the context of Elixir and Phoenix as well, like we have distributed PubSub. I mean, most folks in my experience use the publish notify for PubSub, and it's like we have that already. And we even have, if you're using Yugabyte, you have the consistency guarantees you want as well. So you may be reaching for publish notify because you want to make sure that the remote node gets notified only when the data happens to be replicated. And I don't even think Postgres, high availability Postgres with just replicas gives you that. I'm not sure how it handles it, but in any case, you could use Phoenix PubSub today for all your PubSub. And then if you do need to do a read distantly, it's still going to be consistent because you don't have any stale reads by default. So for me, it's less of an issue. I mean, obviously, if you have a lot of code relying on it today, it changes the equation. But for me, it's less of a need for the Elixir community specifically.
Yeah,
there are also some framework that use it, for example, to detect with a trigger when you do some DDL and notify to some sessions that have cached something or
Yeah, but you could use, going back to the CDC comment, there is something interesting there with, and I'd have to look into the DBZM. I'm not familiar at all, but if you could have like an Elixir client subscribe to CDC and then be doing this same kind of thing, and in that case, you also wouldn't need to use publish notify because you could just subscribe with the query, get the changes, and then broadcast them on behalf of what's happening in the database.
Good point.
So the answer given by both of you satisfied Mohammed. Also, Mohammed, you should find the links that I shared with you on YouTube and LinkedIn as well. So those talk more about Postgres compatibility levels, because there are different compatibility levels: syntax compatibility, feature compatibility, runtime. As long as YugabyteDB runs on Postgres, we by default get most of the features for free, and that's why it's easy to use, let's say, the drivers that we created for Postgres. But also, we are not 100% compatible with Postgres. The only 100% compatible database with Postgres is Postgres, right? All the other databases, let it be Amazon Aurora, etc., AlloyDB by Google, they're not 100% compatible. They have the high-level compatibility, same as YugabyteDB, but some of the features might not be supported for different reasons. But all of the core features, all of the main extensions usually are supported. So take a look, and as always, you can share feedback with us.
Yeah, and I will say, like, with database triggers and like functions, it's the first time I've written like a database stored procedure to do the follower read setting, and that just worked. Like, that is also like magic. It's kind of like, it's like same feelings when I discovered the Erlang VM. Like, create function, and then like it just was created in my SQL shell, and then that's just everywhere on the cluster now. So I haven't found any shortcomings there as far as what I've tried to do. Just standard Postgres stuff.
We don't have 100% features, but we have enough features to have many workarounds with triggers, procedures, complex queries. Yeah.
All right, my friends. We are already over time, but this is usually what happens when we have a very hot topic that guys love to watch. We have so many folks watching us live today, and I bet that many of you will be watching us later on demand, because this recording is already available on YouTube, so just check it out later. Chris, thanks a lot for joining us. That was an incredible demo. We love the use case, and we certainly will collaborate further. We will create some content that will help Elixir, Phoenix, and Flywire users to benefit from from the software stack that you demonstrated today. And thanks a lot, Frank, for just helping us to do a deeper dive into the database topics. So, any other closing thoughts from you before we go and end the stream?
That was really good, and I hope we will have more questions also with people watching online or offline.
Yep. All right then. Have fun and stay tuned for the next episodes. Bye now.
Thanks a lot.